Good afternoon. Welcome. Just before we start this talk, just a reminder, this is our 10th edition, so there are a lot of special things happening. So you may have seen this morning the champagne at breakfast. If you didn't, tomorrow there'll be more. And this afternoon, we have massage chairs close to the reception. They'll be there until 6. So pass by. So welcome.
Thank you.
Nate Warfield.
I'm good.
Floor is yours.
Thanks. Thank you, everybody. Thank you, BruCON, for having me. This is my first BruCON. It has lived up to all the expectations I had and even more, so I'm really happy to be here talking to you folks. And I usually only get 45 minutes or 50 minutes, so the fact that I have an hour means that I can just really enjoy myself. And I have a ton of stuff that I put in just for you guys because, well, that's what I do. So a little bit about myself. My name is Nate Warfield. My day job is working with the Microsoft Security Response Center. I am technically a program manager. What I do in my day job is manage all of the vulnerabilities that come into Microsoft for Windows, the kernel, the server products, the hypervisor, all of the interesting parts of Windows, if you will, which means that last year I got to own the MS-1710 vulnerability, which turned into this little thing called WannaCry, which then turned into NotPetya, as well as a little CPU vulnerability that nobody cared about. So it was a rather busy year for me. Before I came to Microsoft, I spent about 18 years doing network engineering. I've been hacking networks since I was 12 or 13 years old. Dial-up internet was the first time I hacked something over 2400 baud, which kind of dates me. And this talk is a much improved version and much expanded version of what I did at SAS, at Troopers, and at B-Sides this year. If you do the social media, I'm there on Twitter. I also have some of the scripts that I'm going to talk about a little later. I post up on GitHub just because I like to give away stuff for free, and it removes any conflict of interest with my job. So I think it's important, and instead of going through all these bullet points, because if you're in the security field, you probably know all this stuff, I like to start with a little anecdote. Probably in the late 90s, I discovered that a friend of mine who was going to a university across the country, I had just gotten a cable modem, which was just the coolest thing ever, right, in 1997. And I asked them, hey, can you run an ipconfig command on your machine and tell me what you see? And it turns out that this university had connected all of their school's computers to the internet with publicly routable IPs. So I was like, I went into Network Neighborhood in Windows 95, plugged in these settings into my Network Neighborhood browser setting, rebooted, because you did. And after about 10 minutes when the thing came up, I was able to browse all of the machines on their subnet and their university and look at all their file shares, look at all the music that they were pirating, all of the other interesting things that college kids keep on their computers. You fast forward to when I came to Microsoft, I was doing network engineering for them at the time, and we had to turn on an extra DNS endpoint on a system that we already ran DNS from to the internet. It took me 6 weeks of paperwork, approvals, security reviews, paperwork, just to open up UDP 53 to this thing that we already had UDP 53 opened on, right? The point I'm getting at is that there was a lot of things that were done wrong when networking started, and we learned the hard way to stop doing that stuff, right? The thing that's interesting with cloud networking is, as I started looking at it, all of these mistakes that we had stopped making are being made again with cloud networking, right? There's these concept of, everybody says, oh, it's so cool with the cloud, you can do things faster, you don't need a security team, you don't need a network team, you don't need a firewall team, you can have your DevOps guys do everything. It's like, you can, but you lose all of that experience and that skill that your network team, your security team, your firewall team brought to the table. So what's happening is all of these things like NoSQL open to the internet and things not being patched and people spinning up stuff to show off in a sales presentation, and then they leave Mongo on the internet with no password. These aren't even zero-day vulnerabilities, right? Like, I live in the zero-day world. This stuff is just really like permissions problems at cloud scale, which was surprising to me to see that this is actually what had happened. Which led us to last year. Most of these attacks are things that I was tracking in Azure. These are all things that I was watching unfold in real time, and it was a kind of a trip to follow along with this and be like, really, this is like, we've spent hundreds of billions of dollars building clouds, and like, this is what's happening to them. So how did I start finding this stuff? So it was probably August of 2016, somebody decided to go, I saw a blog post about somebody was going into these Redis machines, and they were dropping this key that was called Crackit. And what this was, it was a SSH root host key. So essentially you go in, you drop this key in there, you come back on SSH, you're in as root, you have this server. I'm like, okay, well that's kind of cool. Seems kind of useless, but that's cool. So didn't really think anything of it. Fast forward to March of, say, I think it was January, February of 2017, people started doing this with Mongo. They started, and all of a sudden there's like, oh, people are ransomwaring these Mongo databases and all of these other things. So I was like, what is Mongo? And I started looking like, I'd never heard of NoSQL because I'm a network guy, not a server guy. So I went and looked it up, and I'm like, okay, it's this cool server, SQL system that doesn't use authentication. Huh. So all of these quotes that are up here, I pulled these all off the pages of this different, Redis and Mongo and Elasticsearch, where they actually tell you in the documentation, like, don't ever put this on the internet, and like firewall it off or set up a password, and oh, don't put this on the internet. So of course, like, what do people do when you tell them not to do something? They put it on the internet. So this campaign evolved from January of 2017. It kind of peaked out in March, April of 2017, but it's still going on. Really, every NoSQL server that's out there has gotten popped like this. At a certain point, I just said, okay, let me go to Wikipedia, search NoSQL, let me find every single NoSQL product and start cross-searching them and seeing, okay, are these getting popped? And it was like they were just reusing the same technique. This technique, while it looked like ransomware, it wasn't actually ransomware, right? They would go in, they just pull a little Bobby tables, drop the database, leave a ransom note saying, hey, we have your data, send some bitcoins to this address, and you'll get it back. I didn't go so far as looking at that wallet address to see how much money they made. I'm hoping they didn't make anything because there was nothing to get back, right? Globally, in those 3 months, 4 months time span, there was about 120, 130,000 machines that had this happen to them. In Azure, I found, I think this number is a little bit outdated, I think it's around closer to 5,000 machines or VMs that had this done to them, which was surprising to me. So how did I find this stuff? I have the advantage working for Microsoft that I like big data and big weird problems. I kind of tell people if you have a swimming pool full of needles and you want somebody to find the two like blue ones, like I'm the guy that's going to do that. Like my Azure cloud, I've got 2.1 million IP addresses exposed to the internet at any given time, right? So I have this cool, huge data set to look at. The problem is that makes it rather slow. And you probably know where I can see where I'm going with this. Port scanning 2.1 million IPs takes a long time. Every NoSQL solution runs on a different port. So were I to go and search for Mongo or scan, 2 million IPs, I'd have to come back and do it again. And even if I did port scan all of these IP addresses and all of these ports over and over and over again, it's not going to tell me whether these things are compromised because, like I said, you have to actually look at what's the data that's in the MongoDB or in the Elasticsearch instance to see how these things have been popped. So turns out Shodan was amazingly powerful for this. I'd like to tell you that we have some fancy thing that we wrote ourselves at Microsoft that does this, but no, I did all of this stuff with Shodan. Most people were like, hey, this is just an IoT thing. It's where you go to find like creepy webcams and stuff, people's DVRs that are on the internet. I've actually turned it and found it to be a remarkably useful blue team tool. These little screenshot here on the side. So this was the old way that I was doing, where I was just downloading all of this information out of Shodan and using JQ and these other exotic grep strings to pull out the database names and figure out these. So their columns here is IPs. These are the names of these databases that they were changing it to, and then the products that were actually being the different database NoSQL server types. So the thing that I found really cool with Shodan was that I can dump everything out in JSON, right? So instead of, like I said, I need the data that's in there, I want to be able to search it, but I'm lazy, and if I have to do anything more than twice, I want to write code to do it myself. To this end, I was talking with John, the guy that built Shodan, fall of 2017, I was like, you know what? I'm doing all this stuff manually, and it's really only benefiting me, right? Like I can find, my 4,000 IPs that are popped in Azure, but there's like 100,000 other IPs that are out there of something that has been popped in AWS, DigitalOcean, Tencent Cloud, like all of the clouds had this going on. I was like, we should just put this in Showdown. And he's like, well, write the code and I'll put it in there. I'm like, okay. It was a good reason to learn Python. So I ended up I just took the list of downloading every single open database server that Showdown knew about, which was like 200 or 300,000 machines, and then pulling out all the database names and a whole bunch of exotic things that I did to find I found a bunch of other fun stuff too, not just compromised things, but as you might imagine, people put really dumb things on the internet. It was fun to find databases named like credit card transactions and credit card loan applications, Bitcoins. None of this did I actually connect and look at, mind you. I just saw it sort of in passing. So wrote this code, put it in Showdown, and now it's been running for the last year and a half. So you can search this tag compromised, and I update this every few months when I see different stuff going on, and it'll tell you in Showdown like how many systems have been popped. So like as of last week, there's still like 33,000 machines out there that are sitting, like I don't know if they've been reinfected or if they're just whoever owned these VMs forgot about them. But it's funny that a year and a half later, this is like still going on. One thing I should note. That tag compromise search requires you to have an enterprise license to Showdown, which is $10,000 US roughly. So that's one of the first things I put on GitHub was, if you go here, there's a Python script. It's the same code I send John every time I update it. You can just download a JSON file from Showdown, run the script against it. It'll tell you all the IPs that it found that have been popped and what product and what the name of the database was that was compromised. So, like I said, give back, and that's why I'm not trying to sell you guys Showdown. I'm like, you can get it for free if you want. What I found was interesting as I was looking at all this stuff was I started asking myself, okay, 100,000 machines, at least let me look at just Azure, right? I've got 4,000 VMs. Like, these products all tell you, don't do exactly what you did. Does that mean that 4,000 people went in there and said, well, I'm just going to ignore the security warning. I'm going to set this up on the internet. I'm not going to have a password and just YOLO it out and hope that nothing happens. I don't really believe in coincidence. So I said, nah, there's probably something else going on. What I started looking at was default firewall configs for Azure. So Azure does this, and they call it the Network Security Group. What this thing is, it's your virtual machine firewall. When you go into the Azure Gallery, I think is what we're calling it today, and pull out a VM image and go to turn it on, it's one of these optional features. But the fun part about it is the Azure Gallery and the AWS Marketplace, I colloquially call the Google Play stores of the cloud. If you know how the Google Play store has been rife with bad things, the cloud marketplaces are kind of heading that way. So whoever decides to publish these VM images to these cloud marketplaces gets to decide for you what the firewall config is going to be. And it's hard-coded into the image. And you're not even required to look at it when you turn it on, right? You can go and spin up a VM, and whatever the vendor that put this thing in Azure thought you should have, if you don't check it, is what it's going to deploy with. I ended up enumerating the Azure Gallery and looking at every one of the 1,200 and 1,800 VM images, and realized that, let me take a little step back here. With the way the cloud networking is, right, the traditional network model was you had your DMZ and your servers, and you had your backend network that you'd go to connect to it, and then you'd have all your stuff that was exposed to the internet. Right, with the cloud, you don't really have a DMZ. The only way to connect to these things is over the internet, so I can accept that maybe 3389 for Windows, so RDP, or 22 for SSH, that's acceptable. Okay, you're gonna need to get into this box and manage it somehow. So I was expecting, okay, probably everything is exposing something. It turns out all the stuff that Microsoft publishes, we don't expose anything by default, which, yay us. The rest of them, half of them expose ports by default. Okay, it's acceptable. The thing that was funny to me was almost 100% of them expose more than a management port. As I go through and started looking at what ports are open, how many ports are open, the worst offending VM image, which I will not name, opens up 83 ports to the internet when you turn it on, right? I don't know what all these things are. It's one of these paid for images, so I can't even really spin it up and say, is this a good idea? I'm not lying when I tell you that there's VM images that exposed 137, 8, and 9 to the internet. Anybody know what those ports are? Ring a bell? NetBIOS open to the internet by default. Seems like a good idea, right? Yeah, so this, across all of the things that I found in Azure, there's like 562 different ports that people are opening up, like unique things from, let's see, what's the worst I found? No telnet, amazingly, but there's lots of mail ports, file sharing ports, there's a couple file storage things that open up NFS, also good to put on the internet. So what I started realizing was that people don't even know that this is going on. Like, these are mistakes that they're making because they're essentially copy-pastaing somebody else's config on a server and turning it on, and then they're like, my data's been stolen. I'm like, how did this happen? In fairness, AWS does the same thing. This isn't an Azure problem. This is a cloud problem. I did this talk a while back, and somebody was like, no, man. Amazon's so much better. Like, there's no way that they do the same default firewall config. Oh my, yeah, they do. So this is AWS's version of it. I redacted this vendor name, but yeah, if you go through their one-click deployment, they've got all these ports. Like, I mean, I know what 22 and 443 are, but all the rest of these, like, why should this be open by default? And not telling anybody. I mean, this is like a network security 101 problem that we would have stomped out like 15 years ago. It would have never even gotten on the internet. And now people just do this all the time. What's funny, Azure's and Microsoft, we're very API-based, so we love APIs for everything, which is why I can just point at an API, I can enumerate everything that's in Azure and all of the VM images and all the configs, and I can find like the hard-coded default passwords that some vendors put into their configs. That's fun. So AWS doesn't actually let you look at the details like that, and I filed a feature request with them a year ago, and I think they realized what I was doing because I started telling them like, hey, this is really bad to do, and they're like, what do you want this feature for? I'm like, well, I want to see what your firewall configs look like before I turn them on. And yeah, that hasn't happened. But if anybody knows a way to do this, I'm all ears. I've had hundreds of people tell me they know, and there's never an actual way to enumerate this programmatically. So the other thing that's fun in AWS, they've got 11,000 of these Azure Marketplace images, which is like 5 times as many as Microsoft has in the Azure cloud. And what I'm guessing, based on the amount of machines I saw popped in 2017, that it was basically AWS and Azure neck and neck. So I'm guessing that this problem is systemic to them as well as all the other clouds. I kind of got bored after the first two, and I was like, let's be honest, there's AWS and there's Azure and the other clouds. So this is a fun problem. In the sense of people putting things on the internet that they didn't know were on the internet, one of the systems I built was a database that basically pulls open port information out of Shodan and puts it in a database every day, and I can trend the stuff over time. And so I was starting to look like, okay, what other bad things are people doing? What other stuff is getting online that maybe people don't know about? And if you're an IoT person, I know there's one guy I've talked to here that is definitely IoT. This should be disturbing to you. So MQTT, Mosquito something protocol. It's just a message brokering thing, which I didn't realize was used by Facebook Messenger. It's also really popular with like smart home automation and all sorts of other things that you wouldn't want to put on the internet. And so both Azure and AWS have MQTT offerings, right? We swear up and down that they're secure. I haven't actually had a chance to look at them. I think they turn on TLS, at least in Azure. I'm sure AWS probably does. That's not the disturbing part. The disturbing part is how many of these things have gone online, and the more disturbing part to me was how many of them have gone online in the last year. So having all this data is fun because I can do stuff like this. Like, okay, back in, I think before I went to B-Sides, I was like, oh, let me see what this looks like, right? So if I look back at 2017 and 16 and the end of July, there was 30,000, and went up to 435,000 of these things online in a year. A couple days ago, or actually last week before I came out here to Belgium, did the same query, and I'm like, oh, look at that. So 1,485% increase in this thing that IoT, home control, temperature control, that's disturbing to me. And then when I started digging into like what other things use this, I came across something kind of creepy. So there's this piece of software called OwnTracks. OwnTracks is open source. I'm in no way trying to crap on them and talk bad about them, but this is one of the spookiest examples I've seen of things being online that shouldn't be online. Beyond all the webcams, beyond all the Shodan, Shodan Safari stuff that people do. In Germany this year, I was going on Troopers, and I was like, I wonder what kind of stuff I can find with this. So I look up own tracks, like the day before I was going on stage, and I found this IP address, which I redacted because it was like almost real time when I found it. So I was like, okay, what happens if can I connect to this thing? So it turns out I can, because there's no authentication for MQTT. So I just set up a Mosquito client thing, connect to this thing, and I send a subscription, basically say, I want to subscribe to all of the feeds. I'm not sure if it's real evident in the screenshot up here, but there's some funny names like Lenovo, S3 Mini, it looks like Ericsson. When you start looking at these, Huawei, I came across this. I'm like, is that actually latitude and longitude coordinate information? Yeah, it was. So this person, I think this was in the Czech Republic, so I just took the latitude, longitude data, put it into Google, searched it, and I was like, okay, well, here's this little red dot where this person's phone is. At the time, their phone had 90% battery, their connection was good. I can't remember what the ACC was. I was like, okay, well, that's cool, but maybe this is just like some weird piece of information that's been cached. So I went to conference, came back to my hotel later in the evening. I was like, let me go connect back to that thing and see if anything's changed. Yeah, it did. Like 3 or 4 hours later, I was able to see where this person had moved. Like, I can bounce it back and forth a couple times. So that's where they were in the morning, and then that's where they were in the evening. I shouldn't be able to do that on the internet. I shouldn't be able to look at your phone and watch you moving around your neighborhood, right? Like, that to me was disturbing. What was kind of cool about it, and this is one of the things I love about coming to especially these small conferences, is a woman came up to me after the fact, and she was like, that was really cool talk. What was the name of that software? So I was like, oh, it's Own Tracks. And she's like, I work for a group that, we're an international group that helps victims of domestic violence. And she's like, this is the type of software we want to warn our, the people, the women that we work with, because like if they don't know this is on there, like it was one of those weird things that it struck home, right? And I was like, I always think of like, 0 days and exploits and hackers and everything's sort of ephemeral and sort of theoretical. But then to have somebody look at me and be like, you know what, we could keep somebody from getting killed if they know about this. And I was just like, so the point there is don't underestimate the research you do and the things you do, because you never know when outside of the scope of what you're thinking, you might be able to protect somebody or help somebody, it was a really cool feeling for me. In fairness, I was kind of talking smack on Twitter earlier this year, and somebody else had posted a very, very thorough write-up and did the exact same location tracking thing that I did. So being kind of arrogant, I was like, oh, look, somebody's copying my research, and Own Tracks actually reached out to me on Twitter and was like, yeah, nobody's actually paying our attention to our security documentation. It's kind of too bad. And I was like, well, that's fair. So like I said, this is in no way trying to slight Own Tracks. I'm more trying to highlight, like, this is the world we live in, right? If I told you 10 or 15 years ago that I could watch where you go over the internet from like 1,000 miles away, you'd been like, meh, that's like hackers, right? That's not real. So kind of going back to the threat hunting thing, after the success that we had with the tag compromise and showdown and being able to like say, hey, this is an easy way for people to find, compromise in their networks, I was like, well, what other kind of things could we do? And a few months later, a month or two later, this RCE came out for hold on, I forget the name of it. XM mail server, code execution vulnerability, full system access. So the teams at Microsoft were like, hey man, you're the showdown dude. Can you tell us how many of these things we have in Azure? Like how much risk do we run? At the time, I had to do this, download the file. I could download it by product in my organization. Looking into what's called the common platform enumeration field would give me some versioning information. And so I'd parse it out. This was all a manual process, which at the time, with 17,000 IPs that were running some sort of a mail server, finding the 1,200 VMs that were running a vulnerable version of XM in 5 minutes, I was like, that's pretty good, right? But I'm a bit of a perfectionist, so I was like, can we do better? And is there an easier way to do this? So it turns out there is. I worked with John again, and I said, hey, you can probably just map this stuff automatically. And I kind of want to highlight this because one of the Slacks I hang out in, we talk a bunch of threat intel stuff, and we see people on Twitter spreading FUD. And what we did was we incorporated the CPE to CVE mapping. So it basically looks at the version information it gets from Apache or whatever mail server or whatever other system that any server product that supplies a version in its response. Shodan will go and look on this backend database and say, hey, what CVEs might apply to this thing? Once again, this is accessible only via an enterprise API license. However, there's a nuance to this. Like if you search a specific IP address or you do a search and you find something and you click on the details, you can see the vulnerabilities field that it lists out, right? So it says, okay, I'm being nice, I didn't want to put this IP up here, but it'll tell you, okay, these vulnerabilities may apply to this IP address. What we didn't want to do, because the first time back in January, I went to dinner with Mr. Matherly, and it was right after the I forget, it was Autosploit, or it was some script kid, he wrote a Python script that like looked at Shodan and then it tried to auto-pwn things based on what it found. And the idea that we had was like, you know what, this is really cool information to put out there, but what we don't want is the next time there's some vulnerability found in like IIS or Apache, some script kid is just gonna go and pull all this information and just start mass blasting attacks at it. So we said, okay, the only real way to restrict this is to, like, if you've got $10,000 to spend on an API license, you're probably not going to go and try to hack people just for the hell of it. The one nuanced detail too, there's a thing that's, it's not in this view screen, but if you go into like the details section, it'll give you this verified true or false. Verified false means that it's just implied. So there's a lot of times where like it'll say Apache is vulnerable to this thing, but it has to have this specific module enabled, or IIS is vulnerable if it has this specific role enabled. So if it can't tell, it just says, yeah, it might be. It does say verified true on things like if you have SMB open to the internet and you didn't install the patches that we built so nicely all the way down to XP. It'll actually connect, it'll look at it, it'll test to see if the thing is vulnerable, and if it is vulnerable, it'll say, yes, it's verified true to be vulnerable to whatever CV it is, which, like I said, this is a reason why we wouldn't want, you know, your average script kiddie to be able to just pull like tons of machines out of here and just start blasting things at them. Speaking of MS-1710, this was fun. I kind of like, I have a weird love-hate relationship with the shadow brokers. I've still yet to figure out if their broken English is like OPSEC or if this is just really how they talk. And someday I'm going to meet somebody and they're going to talk like this. I'll be like, oh crap, you're real. So I'm not going to go super detailed on this because this has been probably talked about ad nauseum at every conference in the last year and a half, but as we all know, this company, this group, made this a really cool SMB v1 exploit. As one of the guys that saw the exploit, I can tell you it's really freaking cool. Find me outside of this conversation and I can show you something even cooler. This group, of course, added it to their Metasploit clone, and then like any good, you know, tailored access group, they lost control of this tool. Now, what was fun about this was we patched it in March. I think the media has pretty much been agreed that we were tipped off to this, and yeah, we'll just leave it at that. I'm not an authorized Microsoft spokesperson, so I can't comment on it. But what was really cool was we released these patches in March, and then, you know, 31 days later in April, Friday morning, I come in and Shadow Brokers had dropped the password. I was like, oh man, get online, everybody's freaking out. You know, different blogs are like, this is the end, Microsoft's done for, like, you're not gonna recover from this. My team pretty much stopped what we were doing for the entire day, went through every single thing, and we're like, we fixed all of these vulnerabilities a month ago, right? And from MSRC, like, that's huge for us. And then we're like, well, also it's SMB, right? And nobody in there is saying like right mind is going to put SMB on the internet. As it turns out, they did. So, of course, the first thing that they asked me to do is like, hey, Nate, there's like 1 million SMB servers online. How many of these things are in Azure and how many of these things are vulnerable? So, at the time, we only had 14,000 VMs with SMB exposed to the internet running in Azure. This was fun because Shodan had no way to test for it initially, right? It was like we had this cool like exploit kit, we had this cool framework, there was this cool implant, and then some guys from NCC group were nice enough to write a detection tool, right? They looked at it and said, okay, we can see what it does. You know, like any good operator, you don't want to burn your very, very cool zero-day more than you have to, right? You risk getting it picked up. So after using Eternal Blue to pop the machine, it puts this double pulsar implant, double pulsar, it says, yep, so I'm here with a weird SMB error code. NCC group in a matter of hours had a Python script wrapped up that would just go in, connect, set up the session, send the code, look at the response, and then we're like, okay, well, how many of these are vulnerable? I had to manually process this with a bash loop because, yeah, out of 14,000 IPs. And of course, the first thing that happens, right, what happens when a script kiddie gets like a nation state exploit toolkit, the first thing they do is just point it at the internet and start spraying it. The next morning, I was like, there's only 50 machines that have been exploited in Azure. Like, that's actually cool. Like, that must mean that everybody patched their systems, right? And like, working for the group that does Patch Tuesday, we're like, sweet, we can all go home, mission accomplished, internet's safe, we're done here. Nothing could possibly go wrong, right? Everybody's patched, right, we win, you know? Crack one open, pour one out for the homies. Turns out that wasn't quite the case. So 28 days later, WannaCry drops. Once again, I'm not going to go super in detail in these because I think everybody knows what happened. You folks that are here in Europe, you're probably even closer to this than I was in the US. The points that I want to highlight, though, that was interesting and disturbing to me was that March 7th or March 14th, we patch it. April 14th, the shadow brokers unlock the files. We say, yep, we fixed it. Everybody knew just how bad this stuff was. WannaCry hits 28 days later. Azure, 14,000 VMs. A month and a half later, Azure's SMB exposure had gone up by 13%, right? So it's one of those like, I don't know how many more times you need to be warned, but you know, it's like you had 3 or 4 chances, and like what happens after WannaCry, arguably one of the worst malware outbreaks since the I Love You virus, or you can draw whatever correlations you want. And instead of it getting better, it got worse by double-digit percentages. My theory on WannaCry was, one, it's too bad what happened to malware tech about this. My government can be kind of a bunch of dicks at times. I can say that because I'm here. We'll see how I get back through TSA. The other thing that was interesting about this is it was somewhat low tech. And my theory has always been that it was somewhat of a weapons test. Just because it was like, okay, it just goes through SMB. It was a very effective weapons test, right? If anybody here works or knows somebody who works for Maersk, like that company almost went under because of this weapons test. But it was kind of dumb, right? I mean, you have this super cool nation state 0-day, and all you do is put ransomware on it that has a kill switch domain that you can find in a matter of like, what did it take, Marcus, like 10, 15 minutes to figure this out? Like, that's not really nation state level. That's like, yeah, something doesn't add up. Then of course you have NotPetya, which is like perfect cyber weapon, and I have no idea what country in the world would hate Ukraine enough to build a cyber weapon to try to take them out. I'm not a lawyer, I will not comment on that. But this was high tech. And the thing that was fun about this is it used all of our favorite tools, right? IPsExec, Mimikatz, and then if all else fails, it can just fall back on an unpatched VM. What was terrifying about this, as we looked at it in Microsoft, was the fact that it didn't matter if you were patched, right? So your gigantic network of machines, and this will make a little bit, the creepy part will get a little bit creepier in a second. All you need is one box that you forgot to patch. So like that one thing your sales guy turned on in the cloud and didn't forgot to patch because either he doesn't work there, or he doesn't care, or he doesn't know what patching is. Well, what if you have enough money to have what's called ExpressRoute? Anybody heard of ExpressRoute or Direct Connect if you're using the cloud? So yeah, if it sounds like a VPN, it's totally a VPN. So piecing this together, the NotPetya escaping Ukraine, I've somewhat theorized, and I've yet to hear otherwise. My theory is that it got out mostly because of point-to-point VPN links, right? It was such a targeted attack of MEDocs and backdooring an update thing and then kicking off an update, and like the software that's only used in one country, like how would it get out if not for VPN links? So put all this together of like your cloud subscription with ports open and things that you forgot and an unpatched server and an attack that goes over VPN. Also, how do you manage the ACLs on your cloud subscriptions? Clouds are good at a lot of things. Static IPs is not really one of them. So I know with Azure, and I think AWS does the same thing, you can get a master list of with Azure, we have all the Azure regions, and you can download an XML file that's got, all of the possible networks that could be in there. What it doesn't do is it doesn't guarantee you disclaimer, unless you pay us enough money, it doesn't guarantee you a hard IP for that specific box. I've had folks come up to me afterwards earlier this year, and they're like, yeah, that was really creepy. You see, we couldn't figure out how to ACL off, Azure via express route, so we just allowed the entire Azure region in through our firewall. I'm like, you did what? They're like, well, our CEO kept calling us up, and something, we'd have to reboot and patch, and something wouldn't work. So we finally just said, screw it. We pull down the XML and allow the entire Azure West region in. I'm like, that's a bad idea. There is ways to do this. Please don't ask me. I'm not the guy that does that. I like to point fingers and say this is bad. If you have Azure, your sales guy can probably help you out. There is better ways to do this, but it was one of those. As I started to think in worst case scenarios, I'm like, this is just a bomb waiting to go off, right? The other thing that's fun is while Microsoft spends billions, and I mean billions of dollars making Azure secure, your security of your cloud subscription is your problem. I shouldn't say your problem, your responsibility. In fact, Jeffrey Snover, the guy behind the Azure Stack, sort of like Azure on-premises thing, he'll say this to your face, he'll say this publicly. He's like, yeah, we spend tons and tons of money securing Azure. As one of the other things that I run in MSRC is hypervisor vulnerabilities that come in. While I can't talk publicly about how we fix them, there is a special magic dance we do because, as you would guess, we don't reboot all of the millions of Azure hosts on Patch Tuesday, right? So the thing about it is that's how we secure our stuff. How you secure your stuff, we build you a platform. If you're not paying attention to what you're doing on our platform, that's unfortunately not our problem. It's not our problem, but it's not something that we can protect you from. We can't save you from yourself. You've probably got anybody that's in the cloud has already had their IT policies. They've already had a data center and a model of, we patch things at a certain cadence and we have all these access controls. What's spooky to me is when I've talked to folks and they've been like, they kind of view cloud as this weird little, it's almost like a side project, right? They're like, people are like, well, everybody's going to the cloud, so we should go to the cloud. Well, why? Well, because that's where the future is. It's just this, there is no cloud, right? It's somebody else's computer. Doing it wrong is just setting you up for trouble. And people with the old school mentality, and I'm one of them, like my stuff in Azure, I always deploy it as the IaaS, right? Infrastructure as a service, where you own patching. It's kind of like the fiefdom that you have right now with your data center. You own everything except the hardware is your problem, right? You're not really getting the most out of what a cloud is designed and to do. And then all of the things you got rid of your other teams and your DevOps bros are doing, well, you still have these responsibilities. There's just not as many people to do it for you. Not to be totally gloom and doom here. Of course, people are like, well, patching causes downtime, and it's complicated, and we've all heard the same thing. The thing that's scary is people are like, oh no, I'm in the cloud, my cloud provider patches everything for me. You think so? No, not necessarily, and never do we patch IaaS. If you're running infrastructure as a service, I'm serious, that is your fiefdom, except that you don't own the hardware. We are not going to touch it, we don't look at it. If it gets popped, we may not even know unless you're running Azure Security Center or one of the agents, or I don't know if CrowdStrike or one of these guys has agents for Azure yet, but it's your network at that point. And you're paying, let's be honest, it costs more to run in the cloud than it did with the old school models. So you're paying more to get the same thing you had before. PaaS and SaaS, these are the two things. If you're going to go to the cloud, please go with this if you can, and if you can't, go with PaaS. Again, I'm not a sales guy, so this is very high level. If you want more information, find me afterwards. I could try to get you in contact with the right folks. With PaaS and SaaS, it's sort of a shared responsibility model. With SaaS, software as a service model, we patch everything. Everything is done for you. You just deploy it, forget about it, go home, have a beer. You're done. You don't have to ever worry about patching it. It's all our problem. With PaaS, it's generally things that may not work perfectly in a SaaS environment, right? So maybe you've got some funky middleware, you have some custom code that you can't quite use the little perfect containerized things that we give you, but you can still get a lot of this done by us. You have to set up, I think they call them failure domains, but essentially it's if you've ever worked with load balancers containers. You set up and say, okay, well, here's my primary machine, here's my backup machine, upgrade them in this order. And then what will happen is we'll go in and we'll say, okay, we'll upgrade this one, we'll fail your traffic over, upgrade the next one, comes back. You have to configure it on the front end, but after it's configured, it's all done in the background, right? So like, seriously, like, do these, please, do these, and you'll, and victory. Like doing these, just stop, please stop. Otherwise, your machines might end up in my next talk. So that is another fun part, cloud marketplaces. And I try not to be too negative about this because I work for a company that builds a cloud, but honestly, these are supply chains. I've said this, I looked at slides that I did earlier this year, and I said cloud marketplaces might become supply chains, and then the internet was nice enough to just make me right. And in the last couple months, Docker Hub and AMI images have both been found like pre-configured, pre-malwared, crypto mining, put it up there. It's like, I'm like, this is the Google Play Store all over again, except it's way more expensive and like the risks are far, far like more serious here. These are high value targets, right? The people that are going to go into a cloud is probably not your local pizzeria or, you know, the dry cleaners down the street. Like, these are people that have the money to pay for a cloud subscription, and their data is going to be fun for you, or very juicy for an attacker. The other thing that's fun is, now, I actually asked my boss as I was doing this, I was like, hey, can I build like a special image and try to get it published in the Azure Marketplace? He's like, what do you mean special? I was like, well, all of these networks, all these clouds allow outbound connectivity by default. At least AWS used to. They might have stopped, but I know with Azure, you turn it on, outbound everything is allowed. It's like, I could build an image that phones home after a certain point in time. There's these things, if you use clouds, you probably know like the instance metadata systems, where it's this non-routable IP that you can hit from your cloud VM, and it tells you all sorts of information about the subscription. And there's some folks that have done research on how you can actually use this to laterally move, and like if you've incorrectly set up your key vault or some of your like high security things, you can get information out of there like you would not want to put on the internet. And he kind of looked at me and said, you want to do what? I'm like, I want to build an image that phones home and tells me who turned it on and what their subscription ID was. And he's like, no, they will sue you and then they will fire you. So, but I guarantee you there's somebody out there that's doing this. I haven't found it, but the amount of validation that we do for third-party IaaS images, like, because the stuff that Microsoft publishes, right? Anything that's Windows or any of our products, we do it. We update it every month when we ship patches. The third-party stuff, so all your open source vendors, all these other groups, like, we probably virus scan it. We do a little bit of other validation. We did recently add some code that looks for crypto miners. So if you try to run crypto mining on a VM, it'll actually flag you and it'll send you a nasty gram and maybe turn off your stuff. But if you're clever, like an attackers are going to be, there's no reason you couldn't get one of these past people. They're also really old. And the thing with IaaS, as I mentioned, that you're not taking advantage of what clouds are designed to do. When you deploy an IaaS image, you're copy-pasting whatever it was when it was put up there. So they're old, they might have vulnerabilities, they might have misconfigurations, and even if we find a vulnerability or we find somebody that's got malicious software running in this thing, if we go back and have them fix it, you still have that problem, right? There's no retroactive patching of these things. Everybody that deployed it, they copy-pasted the problem, they still got the problem until they go and blow that thing away or fix it themselves. So what I would suggest is if you really need to run IaaS, AWS does this, Azure does this, you can build your own custom image. You can say, okay, I'm going to do this basic configuration, I'm going to have it set up exactly the way I want it, secured the way I want it, and it's only available to me, and that way when you turn it on, you know, I mean, like, would you just run any specific piece of code out of the Google Play Store, right? Would you trust just some random, if I give you something on a USB stick and say, hey, trust your business is this, you probably aren't going to do it. Don't do that when you're running in the cloud, please. So, 2018 has become the year of the crypto miner. As we found out shortly after WannaCry, NotPetya, ransomware is not really that profitable, right? From like large scale, it kills the host, it's super noisy, you know, you're not going to get away with it for very long before people realize what's going on. Attackers figure this out too, and so last year, or actually early this year, they stopped trying to ransomware databases, and instead they started dropping in Monero and CoinHive stuff into these unsecured DBs. S3 buckets they're going after. That's not my thing. But what's funny is what makes this unique is that after 30 plus years of the internet and all this billions and billions of dollars we've spent, like what we've finally done is we've finally enabled people to physically steal from you across the internet, right? 20 years ago, I loved MP3s. I think actually that technology was invented somewhere close here, right? Fraunhofer. But it was like pirating music, right? Okay, I'm stealing things. Well, not really. You're just copying music like you would off the radio. Now you can actually steal from people, right? Now I can go and I can run up your power bill and you can get billed for $200,000 and I get to go cash out the cryptocurrency. Like, it's an interesting thought that we've done all this work just to enable people to do this thing. To this end, this was a fun one. So going back to what this talk is about, of finding compromise and finding attacks in Azure, this was one I couldn't find on Shodan. But I was tipped off to it by somebody at Troopers this year. And it turned out, which was Docker, TCP 2375, no auth, HTTP, because why wouldn't you run your container administration thing with no authentication and, no security? What I ended up doing is having to go through and just manually scripted this out, pulled all this information. What they were doing was they were just going into these Docker boxes, popping in a special image with this XMRig Monero miner. The reason that I got tipped off and what we got involved was they hacked into customer VMs in Europe, like paying customers. They hacked their VMs, and then they set up Monero mining proxies. So instead of your wallet mining coming from like 10,000 IP addresses, it looked like it just came from 2 IP addresses. This was fun because we could actually take this down. Like once I found it and realized where it was coming from, these guys were so arrogant. They had a GitHub page with like issues and everything. Like they had a whole page for the miner, and people were like, "Yeah, I'm having problems getting this thing and working," and blah blah blah. And they're like, "Oh yeah, we fixed it with this git commit." And I'm just like, dude, seriously? Like, it's a business, right? These guys were nice that in the sense that once we figured it out, it actually got to the point where the lawyer said, you can't be involved in this and we'll handle it from here. But it's not going on in Azure anymore. This type of an attack pattern is still going on. There's some guys on Twitter that talk about it, but yeah, they're still mining Monero with Docker. What's funny about it is when you talk about the amount of money you make mining cryptocurrency in the cloud versus how much it costs, it's somewhere around 20 times more, like the amount of what you'll pay in Azure credits, it's about 20 times more than what you'll make in cryptocurrency. I mean, they don't care, right? Because it's your bill at the end of the day, but it's like, you run $2 or $3 million worth of, Azure like compute time, and they'll maybe make like $50,000, $60,000 out of it. It's ridiculous. And the thing that I love and hate about Monero is you can't find out how much money they made. So while I found hundreds of these things and they were all mining for one wallet address, Monero is designed to prevent you from finding it out. If anybody knows how to do it, I still have those addresses floating around somewhere. I'm always curious, like, was it even remotely profitable? Like what I wanted to see is how close and how quickly did we catch them, right? Had they been doing it for, a couple of days, a couple of weeks, a couple of months? Yeah, and like I said, shout out to Troopers, make the world a safer place. If I hadn't been there, I never would have found out about this. So the guy who told me about it asked to remain anonymous, so I won't mention him. So that's kind of wrapping up a lot of the stuff that I've used to find things looking out from the internet looking to the network. One of the things that I'm super stoked about, and it's what I've been doing a lot of research with, is a new system, right? So Shodan's great. You can find all these things if they're internet facing. Like I mentioned, like it's great for things like NoSQL. It's bad for things like SMB or RDP. Also, what Shodan can't really do is tell you about attacks coming out of a network. So they're not really invisible anymore. This system called Gray Noise, turns out the guy, Andrew Morris, who built it, I believe he used to be with Endgame. There's quite a few folks that are here that know him. So I've gotten to know him in the last few months, and I've got a bunch of really cool data from his system. Shodan is also consuming this now. I can't remember if Tag Scanner requires enterprise access, but he's feeding his data into Shodan, so you can see like how many IPs have been seen scanning the internet, right? Turns out like Asia and Brazil are very popular. Actually, the breakdown here is pretty even. But yeah, like 400,000 IP addresses at any given time are out scanning the internet looking for everything from telnet to SMB. Hold on, I won't talk over my slides. The thing that I really like, being a data nerd, is it's tons of metadata. Like some of the guys from, I think, Rapid7 do some statistical things on, like, they can see how many people are looking for SMB or how many people are looking for Mongo. But it's sort of abstracted away. So you're like, yeah, we have this many, 20,000 IP addresses. I'm not sure if Rapid7 lets you get super granular because I don't have access to it. It's in no way a diss on them, but I do have beta access to a gray noise. So what I started doing was saying, okay, let me try to build some correlations between what's going on, right? Like if I see something scanning my machines on SMB and SMB is open to the internet, like the logical way I would think is, okay, this is a worm of some sort, right? Somebody's popped this thing over the internet on SMB and it's been repurposed to scan for SMB. I wrote, I can't remember if I put the Python script on GitHub, but I wrote a little wrapper script that does this. It looks up Shodan, it looks up gray noise, matches the two things up, and then if the ports match up, it's like, yep, this is probably a bot. What's cool about this is the detections that you can start to pick up. There's a Slack channel that I hang out with Andrew and guys from Rapid7 and Endgame and Binary Edge, and we just sit and we compare notes, and when new attacks come out, we try to figure out how to signature them. So the gray noise, it's more than just IP tables with a logging function, right? It's actually got some level of honeypot where it'll let you set up the connection, it'll wait for you to send a payload, and it'll look at what you're doing so we can try to figure out, like, what are these guys actually trying to exploit? Was fun was this IIS web dev thing. This was what I believe they called, the NSA called this exploding can. It was also part of the Shadow Brokers drop. We fixed it in 2017. People started actually scanning and probing for this stuff fairly recently, and because I can track this stuff within a daily job, I'm able to start looking at trends over time, right? And I've only been collecting the statistics for like 2 weeks, so this is super new data. But when I came here, I was like, you know what? I want to give BruCON something unique because I don't know, this conference is awesome, and everybody I've met here has been cool. And JBoss, Drupal, Mirai. I mean, yeah, Mirai's not that big news. Everybody tracks Mirai. But it's nice to be able to say, okay, I'm starting to be able to draw patterns of what networks in the world are doing what things. And being a network guy, to me, like I live in ASNs, right, autonomous systems, I always look at it like that's your zip code, that's your telephone area code. I can start to look at like, what are these neighborhoods in the internet looking for? And it's actually not the same thing, which was surprising to me. I was just figuring, it's just going to be, at a certain point, everybody's looking for the same thing. They're really not. What's fun, too, I didn't realize some of these bot herders are so dumb, they actually put the user agent string tells you what botnet it's coming from. So like all you have to do is say, oh look, here's something that says Zemu. Okay, that's Zemu botnet. Like, thanks for telling us who you are. This one right here, oops, this is supposed to be on a different slide. This is the T-Mobile network looking for the ADB exploit that came out for Android. My freaking cell phone carrier is scanning the internet looking for this. I'm not sure why. What I also wanted to do, like I said, I like to customize stuff. As I was at the hotel the other night, I was like, I wonder what Belgium's networks look like. Right? I know the worst neighborhoods. The worst neighborhoods are definitely a couple places in the Middle East and a whole bunch of places in Asia. I'm not going to name any names. So I looked up two of the biggest ISPs in Belgium. Anybody that lives here probably knows, one, how awesome is it you have an ISP called Skynet, and then Telnet BBVA. So I was like, okay, these are the two biggest ones. Like, let's see what's coming out of these networks. Yeah, I had to do it. Sorry. So Skynet is 6848, right? I'm like, okay, well, what's been coming out of here in the last few days? Not that much. I mean, this is 3 days worth of stuff. There's like I took out the IP addresses because I'm not trying to shame anybody or get anybody in trouble. Just a handful of Mirai and a couple of Telnet worms. I'm like, okay, that's not bad, right? What about this other guy here, Telnet? Same thing, although they're a little bit more unique. There's some PHP myadmin worms coming out of there, and they're also trying the exploding can exploit. But okay, not bad. And then I was like, well, let's get creative. Like, what about the Novotel hotel network? Like, what's coming out of there? Almost nothing. What's cool about this, and I'm kind of disappointed in you hackers, notice that there's nothing that's come out since the 26th of September. So unless you guys got super good OPSEC in the last few weeks, you're not scanning the internet in any sort of like attack fashion out of the hotel, which is cool. So I thought that was kind of fun, and I'm trying to figure out how to really make this data useful for people, right? Of being able to like understand, like, you know, you're going around your city, you know when you're in a bad neighborhood. I'm trying to figure out a way to do this sort of like an autonomous system where like, okay, like these are the bad neighborhoods of the internet. Like maybe you should be more careful when traffic is coming out of here. Maybe if one of these things touches your server, you should know about it. Like I'm being probed by something that's historically a very bad place. Belgian network's very clean. Good job. Proud of you guys. The other things that I found was fun, and this is where the networks that aren't good, right? And being a cloud guy, malicious cloud tenants, right? Compromise in Azure. This is what it comes down to. What's really bad about this is these attacks come out of your cloud, my cloud, as well as other people's clouds. What have we got here? So I believe this is DigitalOcean, and then AWS 16.05.09, and then 8075 is Azure. DigitalOcean is definitely one of the worst ones, and they're very unique. What I found was interesting was how much Mirai is coming out of cloud networks, right? I always kind of thought Mirai is like a set-top box, like a hardware device, you know, DVR or a webcam that you forgot to update. The amount of Mirai coming out of clouds was surprising, and I'm not really, you know, if anybody has theory, find me afterwards. I love to talk this stuff. So it was kind of fun to be able to build some patterns and say, okay, well, I know that, you know, people in Azure are looking for certain things. I only have 5 Mirai versus, and this is, I should mention, this is only 30 days. The last 30 days of data out of Grey Noise is what I'm getting this from. Then we go over here to, I believe this is a Tencent's cloud in China. I'm not trying to shame anybody, but man, they are very interested in PHP. In fact, when I looked at the overall, as far as the global stuff that I see in Grey Noise, like they are hands down the most interested in PHP and like PHP MyAdmin attacks. It's weird, right? This is something I expected would just be the same across everything, but it's not, and it's cool. I'm a data nerd. Oh yeah, my cell carrier is full of Mirai. Like 6,500 IPs apparently are in my cell phone network. It's trying to pop other machines. If you work from T-Mobile and you want to talk to me, let's talk. Also, if you're watching online, T-Mobile, please fix it. I pay you money. So, none of this data is going to be lost in time. This is the cool stuff. What I'm hoping to do with this data is be able to start like being able to look at trends of attacks or trends of scanning and watching things lead up and then finding an attack that happens, right? So. This was, as we sat and talked in Slack and said, oh, this second Apache Struts, not the one that took down Equifax, but then one that came afterwards. Initially, we're like, okay, it came out. We spent half an afternoon trying to figure out detections. Does anybody have an exploit? Does anybody know what this looks like? Let's put this into Grey Noise. A couple days later, we had a detection for it, and Grey Noise started picking up this trend of like, okay, August 24th, we got 1 IP. August 27th, 3 IPs. I haven't actually gone back to see how many of these things are going now, but it'll be, what I'm hoping to do is figure out when an exploit drops, can we start to draw like any sort of idea on like how long does it take between an exploit getting on the internet and it being put into some sort of commodity malware botnet type of a thing, right? Just like reduce the amount of we don't know factor and take some of the power away from the attackers and give it back to our guys, right? There's something coming out of Iran. I'm not really sure what it is, and I'm not going to talk publicly about it. If you want to talk to me privately, I'm happy to do it. I'm not entirely sure what it is, whether it's an attack or if it's a human, like something that could be censorship related, and I'm a little bit leery of getting anybody injured or hurt. If you want to talk to me, please find me afterwards. I've been talking discreetly with a bunch of folks, and we can't figure out what it is, but I'm not going to say it in front of a camera and on the internet. This is the focus. This data out of Grey Noise is the focus of a ton of research. I'm hoping to have a whole entire new talk for late 2019 based on this. Right now I'm just drowning in data, but I'm super stoked because I have more data than I know what to do with. So yeah, DerbyCon hopefully next year. Fingers crossed. That kind of wraps it up. I'm going to give you a few key takeaways. If you're running in the cloud, if you're going to run IaaS, I still don't think you should, but if you have to, remember, whoever built that thing was not you. You don't know what it has. You don't know how old it is. Update that thing as soon as you turn it on, all right? This is common sense stuff, and I'm sure you're all very smart people, but I see this attack happening so many times, I'm just going to repeat it. Update your VMs. Look at your firewall settings, please, right? You wouldn't let your average, you wouldn't let your janitor put an internet system on the internet, right? So you don't know who put this thing in the cloud gallery. Don't trust that they set it up right for you. Make sure you check it, right? It's easy to do. You can fix it it later if it's wrong, but it's better just to do it right off the bat. Sensitive roles, build your own. Okay? Roll your own. Don't worry about it. You know what it has. You know what it doesn't have. You know it's secure when you turn it on. Something that I've been working with, and I don't have hard data on this, but as you're starting to actually be more, it's now it has a red box around the firewall settings. Like you can still bypass turning, like actually reviewing them, but it's a red box instead of a gray box. I'd like it if they would give stuff like version information for the daemons, and the age of the IaaS image would be great to know too. It's all in an API. If you want information, I'll share the code that I wrote that enumerates it. You can do whatever you want with it or expand it and share it with the world. And then, not a sales guy, but if you run Azure Security Center, the free tier will give you some basic recommendations and tell you whether you're doing something totally stupid, and then if you want any more details, you're going to have to pay for it. So that wraps it up for me. If you want to follow me on Twitter, you can. Thank you again for having me. I think I've got a minute for questions. Went a little long.